By now you have learned the notation for vectors, standard unit vectors, and you learned the basic vector operations. Here's my challenges for you. Can you solve these two problems? Find me the vector 5u minus 2v in this problem, and find me 3u plus 4v in this problem for me. Pause the video and continue watching this video once you finish your solution. So here's my solution, and see if we will get the same answer. 5u minus 2v. So 5v is 5 times a vector v minus 2 I kept saying v, sorry. Minus 2v, so 2 times minus 107. Okay? So we do multiplications first. I get 10, 5, 15 for 5u. And I get minus 2, 0, 14 for the 2v. Now I do subtractions. So 10 minus negative 2, that gives me 12. 5 minus 0, that's 0. 15 minus 14, I get 1. This is my answer for 5u minus 2v. Do you have the same answer? Okay. Let's move to the next one. Given u being 5i plus 2j and 7i minus j, you can sort of guess. I should be a little more clear. I should have said they are vectors in R2. Okay? So then what do we have? First, we need to be able to know how to convert this. So 5i, remember I is the unit vector in the x direction, and j is a unit vector in the y direction. So I end up having 5, 2. Okay? But I don't have to write this out because I know for the I, except the x direction, everything else is 0. So it's always 5 times 1 in the x direction. So I would always have 5 in the x direction. And same here. I will always have 2 and 0, whatever else. It doesn't matter if I'm in R2 or in R3. Okay? So the v, by the same token, 7 times I, what does that mean? It's 7, 0, because except the x direction, everything else is 0. Right now I only have the y component, so I have 0 here. And minus j is 0 in the x direction and 1 in the y direction, so minus 1 here. Okay? So a quick tip is whenever I have ai plus bj in R2, if I want to write it out, what do I have? It's always AB. Okay? And you can imagine if I have AI plus BJ plus CK in R3. What would it be like? So this will be the vector with A in the x component, B in the y component, and the C in the z component. If you don't believe me, you should work this out. So you know I is a vector 1, 0, 0, J is a vector 0, 1, 0, K is a vector 0, 1, 0. So you can work this out and see if you get AB and ABC for these two cases. Okay, so this is just a side tip. We do not have to write this out all the time. We can just jump to the explicit solution there. All right, so now I'm looking for 3U plus 4V, and that's 3 times 5, 2 plus 4V, that's 7 times minus 1. So I have 15, 6 plus 28 minus 4. Combine this. 15 plus 28, that's 43. 6 minus 4, that's a 2. So this is my final answer. Okay. All right. I wanna give you an alternative solution as well. So I'm gonna erase this board. Pause the video if you need to until you finish writing. Okay, so I'm gonna erase this. I'm giving you an alternative way to find 7U plus 4V. Okay, so 3U plus 4V. I can write this as 3. Now U is 5I plus 2J, and plus 4V, V is 7I minus J. Okay, so 3 times 5I, that's just 15I, right? And then plus 6J. So this part is 3U plus 28I minus 4J. Okay? So now I can combine the part that has I, the parts that have I. So altogether I have 43I, and for the J I have 6J minus 4J, so altogether it's 2J. Alright, so according to the tip that we talked about, if you want to, you don't have to. If you want to, you know this is the factor 43, 2. Okay, so just a different ways of solving it. Whichever way you feel more comfortable, you can just stick with it. All right.